Welcome in our mathematics lesson, and we are still continuing with computation with fractions. And here I want us to look at multiplication and division. Multiplication and division. Previously we have seen how to add and subtract fractions, especially when the denominator is the same and also when the denominators are different. Now, but this time round, I want us to look at the multiplication and division. I want us to evaluate the following questions as we look at how multiplication is done in computing fractions. Evaluate 2 over 5 multiplied by 3 over 7 and 8 over 5 multiplied by 7 over 4. Evaluate 2 over 5 multiplied by 3 over 7 and 8 over 5 multiplied by 7 over 4. So to work out this, as we saw earlier on, is that in multiplication, it is very simple. We multiply the numerators as well as the denominators. As we look at where we have the common factor so that we can be able to cancel where possible. For this particular case, we don't have any factor to the numerator or to the denominator which looks alike so that we can cancel. So this one we shall just take 2 times 3 to get 6 and 5 multiplied by 7 to get 35. So this we multiply straight, and that is what we get, considering that there was no common factor to be cancelled or simplified further. For this second one, we have 8 over 5 multiplied by 7 over 4. Looking closely, you realize that from those numbers we have as numerators, there are some of the denominators which share a common factor, and that is 8 and 4. So you are allowed to cancel or simplify it with the highest common factor between of 8 and 4, and in this case it is 4. So by 4 here, it will give us a 1, and by 4 here gives us a 2. So when you look at this now, we can now multiply 2 multiplied by 7, you get 14, and 5 multiplied by 1, you remain with 5. So in giving your answer, you can simply give it as 14 over 5 as an improper fraction, or as a mixed numeral, which is 2 and 4 over 5. So this one is a mixed numeral, while this other one is an improper fraction. We have to evaluate this. 3 and a third multiplied by 2 and 2 over 5. I'll remind you this. You cannot multiply mixed numerals. For you to be able to multiply mixed numerals, you must convert the mixed numeral into improper fractions, and then you work out by multiplying the numerators as well as the denominators. So in this case, we shall first be required to convert into improper fraction. So 3 times 3 is 9, plus 1 is 10. So this is the same as 10 over 3. 2 times 5 is 10, plus 2 is 12. Looking at this, what is a common factor between the numerators and the denominators? So you realize that 10 and 5 share a common factor, which is 5. So by 5 is 1, and by 5 is 2. 3 and 12 share a common factor, which is 3. By 3 will give us 1, and by 3 here will give us 4. So we remain with 2 times 4, which is 8, over 1 times 1, which is 1. So we can simplify it further and say 8 over 1 is the same as 8. Now, the second part, I want us to deal with the division, and we have to evaluate this. 2 over 5 divided by 3 over 7. We saw earlier on in our previous lesson that when dividing fractions is the same as multiplying by its reciprocal. So I'll ask you, what is the reciprocal of 3 over 7? You should have come up with this idea that to get a reciprocal of a fraction, we swap or we interchange the numerator and the denominator, which means 3 over 7, its reciprocal will be 7 over 3. So there we are. It is now ready for us to do our multiplication. So 2 times 7 is 14, and 5 times 3 is 15. So we end up at 14 over 15 as our final fraction. Evaluate 5 over 8 divided by 15 over 16. This one still requires us to multiply by its reciprocal, so it is always wise for us to be able to find the reciprocal of any fraction, and for this case, the reciprocal of 15 over 16 is what? You should have found it is 16. It is 16 over 15. So if that is the case, what is common? Do we have any of the numerator or denominators sharing a factor? Yes, we have 5, which is shared. By 5 here is 1. By 5 down here, you'll get 3. By 8, 1. By 8 is 2. So you remain with 2 over 3 as your final answer. Take note, you are allowed to cancel where possible, and always in fractions, give your answer in the simplest form. Now, how about when you have been given mixed numerals to divide? Should we divide all numbers alone or fractions alone? Or what approach should we give when evaluating division of mixed numerals? Evaluate 2 1/4 divided by 1 1/3. To evaluate this, first of all, we cannot work out when it is in the state that is in which I'm calling mixed numeral. So what happens here is we do the conversion just the way we did it in multiplying mixed numerals. Convert all this into improper fractions. So the first one will give us 9 over 4. By now you should know how to convert. That is 4 times 2 plus 1. Divide by, this one will give us 3 plus 1, which is 4 over 3. Take note, we are dividing. So don't rush and look at common factors and start simplifying and cancelling. No. We'll go ahead and find the reciprocal of the second fraction, which is 4 over 3. So what is the reciprocal of 4 over 3? You should have found it is 3 over 4. So looking at them, do we have anywhere where we have common factors so that we cancel them? We don't. It was there here, but because it's a division, we don't operate like that. So at this point, we don't have those factors that will be common for both the numerator and the denominator. So we multiplied 9 by 3 is 27. 4 multiplied by 4 is 16. And at that point, we have our solution as 27 over 16, which you can choose to convert into mixed numeral or leave it as it is. So what would it be if you chose to convert? Then it would be 1 and 11 over 16. It is just similar thing. We need to know this. In fractions, it is also important for us to know how we can compare the fractions and know which one is smaller or how small a fraction is compared to another one. How is that one done? I want us to look at groups of fractions and see how we can compare the fractions and say this one is smaller than the other one, or arrange them in ascending or descending order. So given a group of fractions, you should be able to arrange them in either ascending or descending order. We have a group of 5 fractions here: a half, a quarter, a third, a fifth, and a sixth, or we call it 1/6. We want to see which one amongst this one is smallest, or which one amongst this one is the largest or has got the larger value. And also, how do we arrange them? So I want us to arrange this in what we call, I want us to arrange these fractions in an ascending order. For us to do this, we must compare fractions which have the same denominator. These fractions do not have the same denominator, so we shall look for the lowest common multiple or lowest common denominator for all, and then we come up with their equivalent fractions and start comparing the numerators. So if you look at all these, the lowest multiple which can divide all this without a remainder will be 60. So if I take my denominator to be 60, the first one, it is 60 divided by 2, which is 30. 30 times what? 1 is 30. So it means a half is equivalent to 30 over 60. For the second one there. 60 divided by 4 is 15. 15 multiplied by 1 is 15. So a quarter is equivalent to 15 over 60. Then 60 divided by 3 is 20 times 1 is 20. Therefore, a third is equivalent to 20 over 60. 60 divided by 5 is 12. 12 multiplied by 1 will remain with 12 over 60. 12 over 60 is equivalent fraction of 1 over 5. And finally, 60 divided by 6 is 10, and 10 times 1 is 10. So 10 over 60 is equivalent to 1 over 6. So how do we now arrange this? Take note of the location of how they are equivalent, each one on its own. So when we are arranging, we should find out from this which one is the least and which one is the largest. So the least from here, I can see the largest. We want to arrange in ascending order. So the least is this one, followed by this one, followed by this one. So to arrange in ascending, we start with the least. The least is 10 over 60, followed by 12 over 60, followed by 15 over 60, followed by 20 over 60, and finally 30 over 60. When you look at this, we don't leave it this way. What we are to arrange are the original values of the fractions. So we replace these with their equivalent original fractions, which will be now, this one will read as 6th. So in ascending order, we have 1 over 6, 1 over 5, 1 over 4, 1 over 3, and 1 over 2. Sometimes when dealing also with the fractions, we involve brackets and actually mixture of operations where we have addition, subtraction, and even division. I want us to evaluate this problem. Now, we are to evaluate 1 over 2 plus 1 over 3 minus 1 over 4, close the bracket, multiplied by a 5th, divided by a 6th. So the order of operation is very important, and that is what we are going to observe. The order of operation at this point is dealing with the bracket first, that is B for the bracket order of division and multiplication, and then addition and subtraction. This catch word board mass, which means bracket, order, division, multiplication, addition, and subtraction. We need to follow that order here. So can we first remove the brackets? And to remove the brackets, work out with what is inside the brackets. What is inside the brackets here, we need to find the common, least common multiple of 2, 3, and 4. And for this case, it is 12. 12 divided by 2 is 6, times 1 is 6. 12 divided by 3 is 4, times 1 is 4. And 12 divided by 4 is 3, times 1 is 3. This is what is inside the brackets, and then we multiply by a 5th divided by a 6th. So here now, you will find that 6 plus 4 is 10. 10 minus 3 gives us 7. So this part we have 7 over 12. Multiplied by what? 1 over 5. Divide by a sixth. But a sixth is what? If we are dividing, so we need to multiply by the reciprocal. And to multiply by the reciprocal here, we shall multiply by 6 over 1. Now, all this now is a group of fractions, all of them being multiplied. Identify the points where you can simply cancel and do it. So the only highest common factor we have is 6. By 6 here is 1. By 6 here is 2. So we remain with 7 times 1 times 1, which is what? 7. And 2 times 5 times 1, which is 10. So we have been able to reduce this group of numbers with operations until we arrive at a single fraction, which is 7 over 10. Having said that about the fractions, I want to believe you are comfortable with any computations involving fractions. Now, fractions is also related to another subtopic that we call decimals. So how do we relate these two? So I want us to look at decimals, place value, and fraction. Decimal, place value, and fraction or decimal conversions. Now, we saw earlier on that you can represent a fraction either as a decimal or a decimal as a fraction. Both the two, that is the decimal and the fraction, is defined as what forms part of a whole. Part of a whole. For example, if we have this circle divided into 2, then we shall, using fraction, we shall say this side is a half, this side is a half. But using decimal, we shall say this side is 0.5 and the other side is 0.5. You notice that it still forms part of a whole. That's what fraction or decimal is defined as. So our interest first is to know how to label what we call place values. So when dealing with decimals, place values will be extended to start involving numbers, names like tenths, hundredths, and so on. Tenths are those ones which will fall in the category of 1 over 10 if I'm to convert it to fraction, and this one is 1 over 100 and so on. So I want us to look at place values and see how we should be able to do a decimal operation without a problem. And before that, now that we find that fractions and decimals are related, the conversion between the two should be just within our understanding that one can be converted to the other. None of it cannot be converted to the other one. Now, on a place value, which we can use a table to illustrate, this is an illustration of a table which will tell us about the place values. And in a place value table, we should be able to place any number with decimal, irrespective of how many decimal it has or how many whole number part it has. I've given an example of this. This is the same as 262.36. 262.36. From the decimal point on our left represents all numbers. That is the units, the tens, and the hundreds. But from the decimal point to the right, it represents the fraction part of a decimal, which I've called tenths and then hundredths. We can move on, it is endless, thousands, 10,000s, and so on. So when you are asked, for example, to place this number on a place value, place 24.08 on a place value table. The decimal point will remain the same place. Then, on the right after the decimal point is our first digit, which represents units. So the units here is 4. And then the second digit represents what? Tens. And the one for tens, we have 2. After the decimal point on the left, we have the one for tenths being 0, so there's no value there, we have a 0. And 8 is actually representing the hundredths category, so we place it there. So we can say that the place values of this number, the place value for 2 is tens, for 4 is units, for 0 is tenths, and for 8 is hundredths. Now, when is this important when we are carrying out conversions? It is very important because this fractional part will always guide us. The part for the tenths and hundredths will always guide us what fraction is it going to represent. So to convert decimals into fractions, we shall be required to know the following. One, we should make sure that we count the number of decimal places used. We should be able to count the number of decimal places used. I want to take an example here. This is 0.7. Convert 0.7 into a fraction. So we are being told first how many decimal places have been used here. How many decimal places? And you find it is only 1. And on our place value table, if we were to place this one, this would be the point, and this one would be our 7, this one would be 0. So, if it is only 1 decimal point place after the point, then it means the decimal places represents the number of zeros. The number of zeros you must place with the denominator as you convert. When you have, like, for example, say this one has 7. 7 has got 1 decimal point. So that 1 decimal point represents the number of zeros after 1 that you should place as its denominator. What am I trying to say? That this part is the same as if we were to convert this, it will be, we want to remove this. So this one will be like 7 over how many zeros after 1? There is only one decimal place, so there is only 1 0. Remember, this one is equivalent to 7/10. 7/10. So if this is the case, this is why it falls in that category. We looked at the number. We looked at the number of decimal places. We saw we maintain this number without the point, but now we bring in the denominator, and the denominator is known by the number of zeros. The number of zeros are determined by the number of decimal places. We have one decimal place, there will be one 0 at the denominator. Supposing it was 0.64. So this one is the same as 64 over 1. And how many zeros? There are 2 decimal places, so there will be 2 zeros. So it is 64 over 100. But it's always important to simplify. So you simplify this one again by dividing further. And when you simplify, you'll get it is 16 by 4. That is 16 over 25. So this is its simplest form. We have looked at converting if we are dealing only with what? Decimal part. But what about all numbers? All numbers remain the same. If we talk about 2.7, this is the same as 2 plus 0.7. So the whole number remains a whole number, which is 2 plus, now change that one into fraction. It is 7 over 1 and 1 0, which is what? 7 over 10, and becomes 2 and 7 over 10. So what am I trying to say? When dealing with fractions, to convert decimal into fraction, the whole number part here does not change. The major concern is the decimal part, which is converted into fraction part. That is how we should be able to approach it. How about when we are now doing the other way around? We are converting the fractions into decimals. So to convert a fraction into a decimal, what do we require to know? The very first thing is we should be able to actually write the denominator as the power of 10. When we talk about the power of 10, is numbers like 10, 10 power 2, 10 power 3, 10 power 4, and so on. These are denominators with the power of 10. Now, when you having done this, then you simply change that particular fraction into decimal by just a matter of counting. You count. If you had maybe down there was 1 0, it means 1 decimal place. 2 zeros, 2 decimal places. 3 zeros, 3 decimal places. What am I trying to say there? For example, 239 over 1,000. So we are saying the number of zeros determine the number of decimal places. At this point, we don't have decimal places. We know the number of zeros as the denominator. So from the far right, where this number here makes this fraction complete, we shall count the zeros as we move to the left. If the zeros are 3, for this case, then we shall count from here 1, 2, 3, and place a decimal point there. That is 1, 2, 3. This is equivalent to the 3 zeros, so it will become, when you count there, it will become 0 point now, 2, 3, and 9. So this, as long as the denominator is a multiple of 10, then we shall only count the zeros. Let me take a simple fraction like 3 over 10. How many zeros form the denominator? It is only 1. So from these 3, we want to count only one decimal place. So from here, we count 1, we place a decimal point, and 0. So we are saying 3 over 10 is the same as 0.3. It's the same as 0.3. Now, this is when the denominator is a power of 10. What if the denominator is not the power of 10? We want to convert a fraction whose denominator is not the power of 10. So it is very important that for us to convert fractions which don't have their denominators as power of 10, we must first make sure that we have the denominator written as a power of 10 or as a multiple of 10. And what will happen is that we look for an equivalent fraction with a denominator which is a multiple of the earlier denominator and a power of 10, and then we go ahead and solve. For example, 3 over 20. 20 is not a multiple of 10, neither is it a power of 10. So we shall be required to see what to do with this. What can be multiplied by 20 to give us a multiple of 10 here? Like 10, 100, 1,000, and so on. What can be multiplied here? So you multiply here by 5, you will get 100. The same should happen up here, which is 15. We said equivalent fractions can be found by multiplying by the same whole number. That is, if you multiply the numerator by 5, multiply the denominator by 5. Now, we have used the denominator to find the equivalent, to find the denominator who's with the power of 10. So the same, how we acquired this should be applied at the numerator. So we have 15 over 100. So how many zeros are there? 2. So how many decimal places do we expect it to have? 2. So just go and write there 15, 1, 2, that is a decimal point, and you have your answer. So to convert such, you must make sure that you change the denominator to be the power of 10 or a multiple of 10, and then you move ahead and do the conversion. It is not enough to say that we can only use simple method of counting zeros to convert a fraction into decimal. It is not always true like that. The most common method which will never fail, and it is applied in whatever type of fraction and it works, is the method of dividing, the division. We say a fraction means division. It's a quotient. When you have a number like 2 over 3, it is the same as 2 divided by 3. So the easiest way, or the most commonly used way to convert the fractions is by simply dividing. And I'll take, for example, a simple. If you are asked to divide, to convert This is 1 over 4. We have to convert 1 over 4 into a decimal. So this is the same as 1 divided by 4, which can be written as 1 divided, we are dividing by 4. So 1 into 4 is not possible, so we shall put a 0 and add a 0 there for 10 to be 10, and then 10 divided by 4 is 2. 2 times 4 is what? 8. I'll write 8. When you subtract, you remain with what? With 2. Bring a 0 in. This one becomes 20. 20 divided by 4 is 5. 5 times 4 is 20. When you subtract, it is nil. So we now conclude and say that 1 over 4 is the same as what we have up there, 0.25. 0.25. Therefore, we can use the most common way to actually convert fraction into decimal is by dividing numerator by the denominator. Convert the following decimals into fractions. Convert the following decimals into fractions. 0.725 and 5.12. So as we saw earlier on, the number of decimals gives us the number of zeros that the denominator will have after the 1. So 0.725. How many decimal places are there? It is, we have 3 decimal places. Therefore, this will be equivalent to 725 over 1. And how many decimal places? 1, 2, 3. And then you simplify. You go ahead and simplify. When you simplify this, you will get 29 over, shall have 29 over 40. When you simplify this, you will get 29 over 40. You can use a calculator, or you can use a long method as you simplify slowly by looking at the highest common factor, and what you'll get is that. You'll notice that for this case, the highest common factor is 25. So 1000 divided by 25 is 40, and 725 divided by 25 is 29. So this one, we counted the number of decimals to give us the number of zeros, and then we simplified. If it is a whole number and a decimal part, like what we have, 5.12, first 5 will remain. It's a whole number. Our interest is the decimal part. So this one is the same as 5 plus 0.12. So we already have that. So this one gives us 5 plus what? 12, and how many decimal places? There are 2, therefore we shall have 100. 12 over 100. When you simplify that by, I think, 4, you'll have 5 plus 12 by 4 is 3 over 25, which is 5 and 3 over 25. 5 and 3 over 25. So we've been able to use the simple knowledge of just counting the number of decimal places, and the same goes for the zeros at the denominator. We have to convert a 239 divided by 100. So I told you the denominator count the zeros. If it's the power of 10, count the zeros. 1, 2. Then you go again count the number of decimals. So this will be 239, and then from here 1, 2. So you find the decimal point will come here. This one becomes 2.39 with 2 decimal places, equivalent to the 2, which was number of zeros. Now, for the second one, we want to convert, but you notice that it does not have its denominator as the power of 10. So what happens here? First, let us come up with an equivalent fraction whose denominator is the power of 10. And for this case, we shall have to multiply here by 4. We shall get 100 here, right? Multiply the numerator by 4. You will get what? 36. Now we have 36 over 100. At this point, we only need to count the number of decimal places by looking at the number of zeros for the denominator. This one will be 36. From 36, we count here 1, and we count the second one. We place a decimal point and then follow the 0. So this one becomes 0.36. 0.36 becomes our decimal point, decimal number. Now, where else are decimals used? Well, maybe fractions and other things. You notice that in our ordinary life situation, decimals are used in many countries when we are referring to currencies. We use decimals. So most countries' currencies use decimals. We can have $20. We can have $1. What if the dollar is less than 1? It is in cents. Then we can have maybe 80 cents or $0.80. So decimals are very, very important in a real life situation. For fractions, you can always say maybe you fueled your vehicle, maybe half tank, so you are using a fraction. You can say the glass of water is a third full. We are using a fraction. We should apply the idea of decimals and fractions in our real life situations. That is it for today. Thank you.